So good morning, teachers, professors. Thank you for attending this workshop. This is a short workshop we're going to have this morning on a topic we're going to identify as automatic summarization. Automatic summarization. So this is a topic that you will encounter as you go through and you begin teaching the routing and switching for the CCNT certification exam. So again, my name's Dr. Davis. Thank you for attending this workshop. We're going to take about 15 minutes to cover this topic. We'll entertain a few questions as we go through, and should we have enough time at the end of the presentation, we will look at it from a hands-on practical application, both from the equipment we have here in the classroom as well as using Packet Tracer. So why don't we get started? Our objectives this morning, we're going to talk a little bit about reviewing a classful IP addressing. That's critical to understanding how automatic summarization takes place. We'll describe automatic summarization. What is it? How does it work? We're going to identify automatic summarization advantages. What are some of the key advantages to it? We'll also look at the limitations, or what some may identify as disadvantages. And then we'll review automatic summarization via RIP implementation. RIP's not the only aspect of it, but we're just going to use that as an example this morning. And then we'll verify automatic summarization. We'll look at what are some of the fixes, and then we will summarize this morning's workshop. So the first aspect of what we want to talk about this morning is classful IP addresses. Classful. So somebody tell me, what is classful IP addressing? Class A, Class B, that is correct. So when we think about classful IP addressing, IP addresses were initially divided into specific classes. As Mr. Sean just mentioned, Class A. Now, what does the /8 indicate? That's our CIDR notation. Speak up, sir, if you don't mind. That's our CIDR notation. What does the number 8 tell us? The first 8 what are on? First 8 bits, that's correct. You're going to make sure that when you engage with your students that they accurately describe these technical terms. That'll make the difference in their technical interviews as they begin to get careers in this field. Class B/16, indicating that there are 16 network bits, leaving us with 16 host bits. Class C/24, 24 network bits as well. So if you recall from your previous training that the classful boundaries were identified as A, B, and C. Now there are 2 other classes, but they're beyond the scope of what we want to talk about this morning. So we're going to be focusing on A, B, and C. And as we've already discussed, Class A has 8 network bits, Class B has 16, and Class C has 24. Do you recall how the breakdown of these classes are? What is the range of addresses that fall within each class? That is correct. So if we, not quite, but close enough, right? Class A starts out at 1,000,000, and that range goes all the way through 126.255.255.255. So anything in that range is a Class A address. And we got Class B and C respectively. So that's just a refresher on the classful addressing as we know it. Let's go a little bit further. Here's our key topic for this seminar today. Automatic summarization. Here's your textbook definition. A process by which a protocol aggregates routes, and here's the significance of what we just talked about. It aggregates routes at the classful boundaries. At the classful boundaries. So, here's an example. What class address is this? That's a Class B address. We notice 172.30.0.0/16 would be the default CIDR notation. But what you can see is it's been broken down into 3 different subnets, 30.1, 30.2, 30.3, respectively. So that network has been broken down. But automatic summarization, if you look at the definition, aggregates routes at the classful boundary. So what that's saying is a network that has been subnetted 30.1, 30.2, 30.3, and I'm referring to the 2nd and 3rd octets, a network that has been aggregated as such, the router would still advertise that route at the classful boundaries. even though it's been subnetted. If we look at the diagram, we can see here's 1.0, here's 30.2, here's 30.0, and what we're saying is in this presentation, R2, when it communicates with R3, would not acknowledge the three different subnets. It would advertise the automatic summarization boundary, meaning 172.16.0.0. Excuse me, 172.30, not 16. Everybody follow me? Okay. Let's go a little further. So what we're saying is, because of the default behavior of automatic summarization, there's what's called a boundary. See the blue colored box here? That represents the boundary of the automatic summarization aspect of what we just talked about. RIP version 1 is a protocol, routing protocol as you recall, and it fits into what we call classful routing. Yes, sir. Oh, that's an excellent question, Sean. No, they are not. This is not a special router. There's nothing been done that differentiates it from other routers. The aspect of it is it's a router that's running a classful routing protocol, RIP. And because it's running RIP version 1, it becomes the boundary between this network and this network. So as a result, R2 becomes our boundary router, and R2 is the router that's going to advertise that automatic summarization. Good question, sir. Does everybody follow me? So RIP automatically summarized classful networks. Let's go a little further. When you think about RIP, there are two common rules, and you probably remember this from your previous training. If a routing update and the interface it receives belongs to the same network, then the subnet mask of the interface is applied. Because here's what we're talking about. Because RIP version 1 is a classful routing protocol, when updates are exchanged between the routers, what's not included in the updates is the subnet mask. So now you think about this. If router 1, let me go back one slide. If router 1, no, let me use router 2. When router 2 sends an update to router 3, and it does not include the subnet mask, the question becomes, how does a router know what subnet mask to apply to it? Because it has to appear in the routing table. That's where the two rules come into play for us. The routing update that it's received on its interface, if that network is part of the same network, that update is part of the same network, then the router knows to apply the subnet mask of the interface it was received on. You follow me? But if a routing update and the interface it's received on belong to a different network, then the classful subnet mask is applied. Two different aspects. This is how we get to a classful routing protocol. I'll go back one slide to give us a visual. R2 is going to summarize at the classful boundary. We just talked about that, right? So we look here, we can see the classful boundary is 172.30. That's the classful boundary because it's a class B. So when R2 sends 172.30.00 to R3, look at the picture. R3 is going to receive it on this interface, and its address is 192.168.4.8/30. Therefore, the update that it receives, 172.30.00, is on a different network than what R3 is physically connected to. You follow me? So as a result, the second rule will apply because it belongs to a different network. So rather than try to discern the subnet mask from its own physical interface, it'll look at the IP address and say, oh, 172.30 is a class B, and it will apply the default subnet mask to it. Is everybody with me? Yes. Good. So how do we evaluate when a router is running a class full or classless routing protocol? So one of the things we need to remember is that there's the command debug IP rip. And we can actually watch the routing protocol in real time. And this output shows us. If you look right here, it says receiving version 1 update, and it tells us who it's coming from. You see it? So we can see the update in real time. And the significance is version 1, which is class 4. The advantages of automatic summarization. Routing tables are reduced. So instead of having a list of various networks, we summarize at the classful boundary. The receiving router ends up with one entry in its routing table. As a result of that, the routing table is minimized, and now we end up with a faster lookup process. The disadvantage of this, or the limitation, is discontiguous networks. If we have networks where we've subnetted and those two subnets are on different routers, discontiguous would cause us a problem. For example, 172.30 over here, 172.30 over here. We have two networks that are discontiguous. Both R1 and R3 are going to advertise to R2 the classful boundary. So R2 would have the same network appearing in two different locations.
So, Dr. Davis, does the typical student understand the concept of a discontinuous network?
No, they won't. Most cases, they will not. So you're going to need to prepare yourself as instructors to be able to not only explain what's happening, but explain to them the concept of discontiguous and how that applies when they actually design and architect the network in the beginning. When they assign IP addresses, they got to consider what routing protocol am I going to use and discern from there whether maybe I need a different protocol or I need a different network design. Good question, Mr. Shad. So as we get close to the end of this here, configuration and advertising networks. We all know how to configure RIP, really simple. Router RIP, we type in the network statements, 192.168.1.0, and that turns on RIP. Now what's not stated is that's RIP version 1, right? Let's take a look at how we analyze. As we talked about before, if we do a show IP protocol, we can see this is version 1 being utilized, and here's the critical part of what we're talking about today. Automatic network summarization is in effect. So that's how we're able to verify. Now that we understand what automatic summarization is, this is how we verify it. Show IP protocols. So automatic summarization, we've already talked about it. You learned in your previous courses the difference between the different routing protocols. I won't belabor that. What I want to get to is our next slide here. Disabling auto summarization. RIP version 2, as you've learned, allows us to disable automatic summarization. And the way we do that is in the global configuration mode under router RIP version 2, no auto summary. And that turns that off. Yes?
Question. Considering the limitation of RIP version 1, how much time and effort should we as instructors spend on the topic?
Oh, good question. How much time and effort? RIP version 1 becomes an essential teaching tool as instructors. Is it widely deployed in large networks? No. But the functionality of it becomes a powerful teaching aid for you to be able to show the student the results of auto summarization and no auto summarization. So it's critical to it, although don't look for it to be built in large networks going forward. So that's disabling. So in summary, classful IP addressing, we talked about it, class A, B, C, right, /8, 16, and 24. We talked about automatic summarization, understanding aggregation of routes at the classful boundaries. Automatic summarization advantages, routing updates are reduced, and we end up with a faster lookup process. No support for discontiguous networks, and verification, we talked about being able to go in and using things such as the show IP protocol to verify those things. So at this time, we're going to conclude the lecture portion of this seminar, and we're going to transition into our hands-on aspect where you guys are going to go through and we're going to practice in Packet Tracer and utilizing the equipment.